back, or Vitayu in Ukrainian. Have you ever imagined what it would be like to go to space, to walk on the moon, to be the first person to live on Mars? Did you know that right here in Texas, we're on the cutting edge of space exploration? Maybe you've heard of the billionaire Elon Musk or his car company Tesla. He also has a passion for space exploration, so he created a company called SpaceX. Off the coast of Texas, in a tiny town called Boca Chica, is his headquarters, called Starbase. It's near South Padre Island. That's where his team designs and builds and launches rockets. If you have the chance to visit, you should do so. It's super exciting. Take a look. Has anybody heard of Amazon? Well, Amazon's founder, Jeff Bezos, is also in the space race. In the tiny town of Van Horn, Texas, is his company called Blue Origin, where he recently launched and went up in his own rocket. Take a look.
9, 8, 7, 6, 5, 4. Command engine start. 2, 1. Ignition. We got liftoff. Ship has cleared the tower.
And New Shepard has cleared the tower on our way to space with our first human crew. Go, Jeff, go, Mark, go, Molly, go, Oliver. You are going to space. Liquid
desert right now.
Propellants, it's a nice,
as
not just clean in terms of
not only the richest man on Earth, but potentially the oldest person to have ever gone to space, the youngest person to have ever gone to space, and the first time that a U.S. company is carrying a paying passenger to space, as we see this mission underway.
Ukraine is also known for its contributions to space exploration. A Ukrainian man designed and built rockets that launched the first artificial satellite into space, as well as the first animal, the first man, the first woman, the first two-man crew, and the first three-man crew. And nearly 60 years after his time, versions of those very same rockets are being used today. You'd think the man responsible for these achievements would be famous, synonymous with genius, with all kinds of awards and spacecraft named after him. And yet, Yuri Korolov spent his entire career in anonymity, an enigma whose accomplishments remained hidden from public view until he died, and his obituary ran in 1966. A brilliant engineer, Korolov built his first glider at just the age of 17. And after graduating from Kiev Polytechnic Institute in Ukraine, he became interested in rocket propulsion. In 1932, he was appointed head of the Soviet Union Jet Propulsion Research Group, tasked with running the country's rocket development program. The result of his years of work and study was the R-1 rocket, which had a range of 270 kilometers. The next version, the R-2, doubled that range. In 1951, he strapped 2 dogs into an R-2, and he recovered them 100 kilometers away. They survived. His final rocket, the R-7, would change the space game. It was the world's first intercontinental ballistic missile. Take a look.
Korolev's 7th generation rocket, the R-7, would be the game changer as a weapon, but more so as an instrument of science. Designed to carry a 5,400 kilogram warhead, more than 8,000 kilometers, the R-7 was the first intercontinental ballistic missile, and it looked unlike any rocket that had come before it. With a long central core booster surrounded by 4 detachable liquid rocket boosters, the R-7 was designed to provide maximum thrust at launch with the ability to shed its empty fuel tank as it gained altitude and speed. It's a model often used today, but in 1957 it was a revolutionary concept. The R-7 worked, not so much as an ICBM, its range wasn't quite long enough to scare the Americans, but rather as a launch vehicle. On October 4th, 1957, while still officially in the testing phase, an R-7 rocket named Sputnik launched a 57-centimeter artificial satellite of the same name into low Earth orbit. Thanks to Korolev's invention, the space age had begun. And it was just the beginning for Korolev's rocket. Every subsequent Soviet and Russian launch vehicle has used the basic R-7 design. Most of the changes have just involved lengthening the rocket to hold more fuel, allowing it to carry larger payloads. In 1961, an adapted version of the R-7 known as Vostok launched the first human, Yuri Gagarin, into space. Several years later, the Soyuz rocket program began, and it continues to this day. All in all, variations on the R-7 have been launched into space more than 1,700 times. And every time another one goes up there, we have Sergei Korolev, aka the chief designer, to thank.
Let's check in with our friends. I'm applying a force with my arm to cause the paper to drop. What made it move?
A gravitational force applied to the paper caused the paper to drop.
What happens to an object with a force acting on it?
It accelerates or goes faster.
What caused the paper to move? Was it a force?
A force.
Was it a push or pull?
Push.
Today you'll be making a small version of a rocket, since we obviously can't build a real rocket in a classroom. At this point, your teacher might put you into teams. If so, come up with a great name for your team. Your teacher will give you a paper and a data log. First, grab a few crayons or markers and color the rocket body and fins. Then cut out the shape of the rocket body. That's the rectangle. This will be the body tube of the rocket. Then you'll wrap the rectangle around a pencil lengthwise and tape the rectangle so that it forms a tube. Next, very carefully cut out the 2 fins. Align the bottom of the rectangle that extends between the fins with the end of the rocket body and tape the fin to the body tube. Do the same thing for the other fin on the opposite side, making a fin sandwich. Carefully bend the fins on each fin unit 90 degrees so that they're each at a right angle to each other. When you look along the back of the rocket, the fins will form a plus mark. Next, twist the top of the body tube into a nose cone around the sharpened end of your pencil. Measure your nose cone from its base to its tip and record the length on your data log and on the rocket itself. Remove the pencil and replace it with a straw. Your teacher will have created a launch pad and a landing area. Follow her instructions. You may want to test your design on the launching area and use the information to make small adjustments to your rocket. Think about these questions as you're designing your rocket and launching. How does the length of the paper rocket affect how far it flies? Does the shape of the cone affect its flight? Does the placement of the fins affect the overall rocket performance? Your teacher will give you instructions on how she wants you to proceed with the launch. Make sure not to aim the paper rocket at another student. Aim towards the launching pad, then blow into the straw to launch your rocket. Use the data collection sheet to record the distance of your trial runs. In your groups, talk about the results. Why do you think some people's designs went farther than others? How did you get your paper rocket to launch? Was force applied? Was it push or pull? Have fun. I can't wait to see whose rocket goes farthest.
Have fun building your rocket.
Ми раді, що ви завітали до України. We are happy that you visited our country, Ukraine.